Next, we will introduce and discuss the idea of integration. There are two types of integrals, indefinite and definite. The difference between the two is not only in the presence or absence of the limits of integration, but in the origin and the meaning. However, soon we will be convinced that there is a reason why two of these ideas are given the same name. But let's go through the introduction of each one of them briefly. Consider a pair of functions in which one is a derivative of the other. In this example, lowercase f is the derivative of the uppercase f function. And we say the uppercase f is an antiderivative of a lowercase f function. Technically, each function has infinitely many antiderivatives that differ from each other by a constant. So we denote all of them by using the f plus c notation. And we call it the general antiderivative of lowercase f function. So, the indefinite integral, by definition, denotes the general antiderivative of the integrand function. For example, the indefinite integral of 2x is x squared plus c, because the derivative of any function in the form x squared plus c is equal to 2x. On the other hand, let's consider a function that is defined on some closed interval from a to b. We calculate the net area between the function and the x-axis on the interval from a to b as a limit of the Riemann sum and call it the definite integral of f of x from a to b. For example, the integral of 2x from 0 to 1 is equal to 1, because if we look at the graph of the function 2x on the interval from 0 to 1 and compute the area under the graph between 0 and 1, we will get the area that is equal to 1. In summary, to find the indefinite integral means to find the general antiderivative, and to find the definite integral means to find the limit of the Riemann sum or the net area on the interval from a to b. So, for example, let's find the integral on the interval from -1 to 5 of the following function with the following graph. We simply compute the area between the graph and the x-axis within the provided boundaries. Therefore, the definite integral of this function is equal to 11. On the other hand, when finding the indefinite integral, we simply look for a function whose derivative is equal to the given function. Since the derivative of x cubed is 3x squared, the indefinite integral of 3x squared is x cubed plus c. Similarly, since the derivative of square root of x function is 1 over 2 square root of x, the indefinite integral of 1 over 2 square root of x is the square root of x function plus c. We use indefinite integrals to solve the initial value problems. For example, let's find a function whose derivative is 3x squared and the output at 1 is 3. We first find all antiderivatives and then pick the value of c that makes the antiderivative to satisfy the given condition. In this case, such value of c is 2. So the answer is x cubed plus 2. For example, let's find a function whose derivative is 1 over 2 square root of x and the output at 4 is 0. We again first find all antiderivatives and then pick the value of c that makes the antiderivative to satisfy the given condition. In this case, such value of c is -2. So the answer is square root of x function minus 2. Now, let's clear up any confusion about whether to add plus c or not. If you are looking for the general antiderivative, that is, finding the indefinite integral, then the answer will have plus c. However, if you are working on an initial value problem, that is, looking for a particular antiderivative that satisfies a certain condition, then the answer will be just a function. But don't be this guy either. Definite integrals always return just a single number, as they represent areas and not functions. To lay the foundation for studying integrals, we convert the table of the derivatives into a table of integrals by simply switching the sides. This table is only a starting point in our study of integrals, but soon we will expand this table and include many other non-basic antiderivatives. We introduced the idea of integration and discussed the differences between definite and indefinite integrals.